It's okay, bro. I got you.
So suppose you're given a function f of x on an xy plane. Then you take the function and rotate it around the x-axis, like so. But to better demonstrate this, I've sketched out the graph of f of x, which is simply the square root of x. And now this is on the xy plane, and when we rotate it around the x-axis, we're going to get a 3D shape like so. And as you can see, this is rotated, and our shape will look something like this. And now we're being told to find the volume of this. So to find the volume of the 3D shape, you'd simply want to take cylinders of very small thicknesses, and then you'd simply want to go ahead and add them up throughout your function like so. And so this is one example of that cylinder. To find the volume of that cylinder, we need to take the area of that cylinder and times it by its thickness. Now suppose that this is the cylinder. This cross-sectional area right over here will be its area, and it will be simply pi r squared, where r is the radius. Then this right over here would be the thickness. So the radius of the cylinder would simply start off from the x-axis and go and touch the y-axis. The radius would change if you change the position of the cylinder because the function is extending. And so we would say that the radius is simply f of x if this point was x. We say that because the function's value right over here is f of x. And so the radius is going to be f of x. Then we'd also say that the thickness right over here is dx. And so if we go ahead and evaluate the volume of the cylinder, it's going to be the area, which is pi times f of x squared, since the radius is f of x, and then times the thickness, which is dx. Now, this is of course just for one single cylinder. Well, how will we get the total volume? To find the total volume, we'd have to simply put a bunch of cylinders like this. For example, one of them could be here. And yeah, so we'd fill the entire shape with cylinders with the same thickness, however varying radiuses, and by summing up their volumes, we're going to achieve the entire volume of the shape. And since dx is very small, we're going to have to use the integral sign to sum up every single cylinder. So we say that the total volume becomes the integral from a to b of pi times f of x squared dx. And so what this says that is from x equals to a to x equals to b, go ahead and sum up the volumes of each and every cylinder. And hence you would get your total volume.